Hello friends, welcome to this new video on the UDS Services series. In this video, we will understand about the service ECU Reset. We have already seen in the previous video, we have learned about the service Diagnostic Session Control, which is with SID hexadecimal 10. In this video, we will learn about the next UDS service according to ISO 14229 document. It's an ISO document. In part 1, as a part of that, the UDS services, we will learn about the ECU Reset Service. The service ID for this is hexadecimal 11. I am Shambat and I welcome to this video by Vichara Vandana Group. So what is a ECU reset service? ECU reset is a UDS service to reset the server. What do you mean by reset? It means restarting of the server, right? So this service is used when the tester needs the ECU to restart from some point of the start sequence. It can be from power on, that is when the ECU is powered on. Then what are the different sequence of event, what happens. So from that, if the tester wants it to restart from, or from the ignition on point of view, or from the starting of the software application. Here the term application is very important. So when you say the ECU will have to be restarted, right? It can be from different point of time when we want the ECU to restart from. So the tester can request the ECU to restart its processing, and from what point of time it wants to restart, that also it can request as a part of this service. So as you can see, the SID is hexadecimal 11. This contains a subfunction. The service request format is 11, and then we will have the subfunction part, which is also 1 byte long. And the service response is 51, that is for SID we are adding hexadecimal 40, so that becomes 51. Then the same for subfunction will be given, and the power down time. As you can see, I have highlighted the power down time element in a different color. That is because this power down time is applicable only for certain subfunctions. So not for all subfunctions this value will be available. So this is a conditional parameter. So you can see here there is a tester, which is a client, and the ECU, which is a server, which are communicating in UDS. You know, in a UDS we are having a client server kind of a communication happening between them. So the client first sends a request. So UDS request 11, that is ECU reset request, is sent, and the server wants to restart now. Depending on the subfunction which is requested by the tester, it performs the ECU reset if everything is proper, and the ECU sends the response. Yeah, so UDS, this is 51 actually, not 11. So the request response format happens. So now I told that the tester can request for different kinds of resets. That is based on the when the ECU power on happens, that time ignition on happens, start of software application. So these various kinds of points it can choose for the ECU to restart from. So depending on that, we have the types of reset which the tester can request the ECU. UDS defines three standard types of reset and two substandard resets, which are shown here. It also allows the OEM or supplier to define their own reset types as well. Each reset type is assigned a subfunction. So how does the tester request the different type of reset to the ECU? By using the subfunction field of the request message. This is, as I mentioned, is 1 byte long. So if it's 1 byte, that is 8 bits, then it can take the values of minimum 0x00 to 0xFF. So this is the range of values which is possible. Among these, which values are having what reset types is given in this table. As you can see here, the hard reset, key off on reset, and soft reset. These are the three standard types defined by UDS, which I mentioned. There are two substandard resets also defined by UDS, that is enable rapid power shutdown and disable rapid power shutdown. So these takes the values 0x01 to 0x05. Note that 0x00, this is a reserved value. Then from 40 to 5F, it is reserved for the vehicle manufacturer specific, that is OEM. If OEM wants to define their own specific reset types as well, then they can take the values in this range. Let's say 0x45. They can choose this value for subfunction for their own reset type. So OEM has this range, and the suppliers, that is the tier 1 or 2, the suppliers are given a separate range. So if I am supplying the ECU, if I am the manufacturer of the ECU and providing you the ECU, then I am a system supplier. If I am taking that ECU and integrating in the vehicle and I am the manufacturer of the vehicle, the car, then I am the vehicle manufacturer. So for OEMs, this is the range in which they can define their own subfunctions for reset types. This is a range where the system supplier, the ECU manufacturer or tier 1, tier 2 suppliers, these people can define their own reset types in this range. The remaining values, that is 0, 6 to 3F, that is between these, and 7F. These values are reserved by UDS. These subfunction values cannot be taken for any of the reset types. Okay, so in this slide we learned about the reset types, but in order to understand what is a hard reset, what is a key off on reset, what is soft reset, what is enable rapid power shutdown, what is disable rapid power shutdown, what exactly are these reset types, to understand that, first we need to understand the ECU startup sequence in a vehicle. Let's say you are in a vehicle and you enter the vehicle and you do a ignition on. So you put the key and you turn the key in the car, right? So now your car is being started. So all the ECUs needs to wake up, get started, do the initialization. So what happens at this point of time is what we will see in this ECU startup sequence. This can change from one OEM to another OEM, but as a standard, in a generic way, this is how all the startup sequence looks like. When the ignition on signal is detected by the ECU network, then a ECU power up occurs. Then all the peripherals of the ECU are woken up. They perform their startup checks, hardware checks. All those initial tests are performed during the startup peripheral phase. Once the hardware is ready, then the bootloader of the microcontroller in the ECU starts. So here all the initial checks of the bootloader, whether a valid application is available or not, whether the initial memory checks are proper or not. These initial bootloader, whatever performance it has to do, checks it has to do, will be happening. Once the bootloader sees that there is a valid application, then the controller moves from the bootloader to the application part in the software. So the application will start now. When the application startup happens, then all the process initializations are happening. The RAM testing happens and loading of EEPROM to EEPRAM will be occurring. So the non-volatile memory contents whatever is there, that will be loaded to the volatile RAM, which the processor can directly access, right? That will happen after the application startup. Once all these init functions and all are occurred, then it moves to the normal operation. So whatever the ECU's functionality has to happen, the processes which has to happen, those will run normally. So this will be executing again and again and again in the process wise. OS will be taking care of that and all, right? Let's say you have driven the car and the ECUs are performing their actions, tasks, functionalities, whatever, and you have reached your destination and you do a ignition off. Okay, so when you off the car, that time the car is stopped or shut down, but ECUs are still running for a duration of time, a small duration delta time. In that time, what happens? The shutdown sequence will be running. All the deinitialization of the process, unwanted data whichever have been stored will be cleared. The values whichever are there in the EPRAM, from that, the important parts which are configured to be stored in flash or EEPROM, that storing will happen. And after all these actions, what has to happen when the car is stopped, before the ECU goes into sleep or shutdown mode, these actions will happen and then the ECU power down will occur and the vehicle is finally at rest. There is no battery consumption, nothing is going on. The ECUs are in shutdown, the network is stopped, all those parts will occur. So this is a normal vehicle ECU startup sequence. Now we saw that there is hard reset, key off on reset and soft reset. So hard reset is when you perform the hard reset, then the sequence, startup sequence of ECU starts from this point of time. Again the peripherals are started, again the peripheral checks are done, again the control goes to the bootloader startup sequence, again the valid application check is happened, it will be checked, and then again the control will come to application, all the process initializations will be happening, and then it will enter into normal operation mode. But if you request a soft reset as a part of service 11, then ECU power up, shorter peripherals, bootloader control, all these things are not needed. It directly comes at this point where the application is started. The initializations processes all is again occurred. Copying of the EEPROM to EEPRAM is again happening. So the software level of the restarting is taken care by the soft reset, and hence the name soft reset. Even the complete hardware will be reset by the hard reset. That's why this is termed as a hard reset. Now when you talk about the other reset, which is the key off on reset, then it is less complicated than hard reset but more complicated than soft reset. So here you imagine that we did the ignition off, right, and the shutdown sequence started, deinitialization, all these things happened. But before the shutdown sequence is over, before this point or this point, if you do the ignition on again, right, then all these startup peripherals, all these things will not be required again. So it will go to the bootloader startup sequence. It may, wherever it was stopped, that part it will go and it will continue from there. So if you're emulating the key off on reset, then when you do the ignition off and ignition on, whatever sequence is supposed to be done for the ECU, that sequence only will be occurring. So basically, a hard reset is when the complete battery is disconnected from the ECU and the connection of the power is again given back to the ECU. During that time, what sequence of startup should happen in the ECU, that will happen for the hard reset. For key off on, if you do the ignition off and ignition on, that time what startup sequence is supposed to happen for the ECU, that will happen if you trigger the key off on reset. And only if the software will have to be restarted, that is from the application starting, the bootloader has finished its functionality, it has detected that there is a valid application available and the control is given to the application, and then application will take over, right? So if you want the reset to happen in such a way that the restart point should be when the application has taken over the control, then you will trigger the soft reset. Let us see what does the UDS document say about this. So here we have come to the document of the ECU reset. This is ISO 14229 document. So the hard reset. So the subfunction hard reset is hexadecimal 1. This value identifies a hard reset condition which simulates the power on startup sequence, typically performed after a server has been previously disconnected from its power supply, that is battery. The performed action is implementation specific and not defined by a standard. So what it means is, when a power is disconnected and the power connection is given back to the server, what startup sequence should happen is not fixed by a standard. It can be changing from one OEM to other OEM, one car to other car, one ECU to other ECU. So this is not standard, it is not defined by a standard, but implementation specific. It might result in the reinitialization of both volatile memory and non-volatile memory, that is RAM and ROM locations to predetermined values. That is a hard reset. Now what does it say on the key off on reset? That is the second subfunction 0x02. This value identifies a condition similar to a driver turning the ignition key off and back on. This reset condition should simulate a key off on sequence, that is interrupting the switched power supply. The performed action is implementation specific again and not defined by the standard, as I have explained earlier. Typically, the values of non-volatile memory locations are preserved. Volatile memory will be initialized, but still this is just an example, but this can be implementation specific. Then coming to the third, soft reset. This value identifies a soft reset condition, which causes the server to immediately restart the application program if applicable. So this is restarting of the application program only in the software level. The performed action is implementation specific and not defined by the standard, like other two subfunctions as well. A typical action is to restart the application without reinitializing of previously learned configuration data, adaptive factors and long-term adjustments. Okay, so as I explained, when the application is restarted, nothing related to hardware and all is touched. Then we have two special substandard subfunctions, that is enable rapid power shutdown and disable rapid power shutdown. Let us read what it says and then I'll explain it. This subfunction applies to ECUs which are not ignition powered but battery powered only. So when ignition starts, then the ECU will be starting. When ignition is off, then the ECU will go to sleep. Those kind of ECUs, for them, these subfunctions are not applicable. If the ECUs are directly powered by the battery, and as long as the battery connection is there, the ECU will be taking power. For those kind of ECUs only, this subfunction is present. So this subfunction applies to ECUs which are not ignition powered but battery powered only. Therefore, a shutdown forces the sleep mode rather than a power off. Sleep means the power off but still ready for wake up, that is battery powered. The intention of this subfunction is to reduce the standby time of the ECU after ignition is turned into off position. So if a ECU is there which is not connected to the ignition, then when the ignition is made off, then after a predetermined time based on a configuration parameter, this ECU will go into sleep mode. Now this time for which the ECU will be awake after the ignition off, this value I told is a configurable. Now we are able to change that time value based on this subfunction of the ECU reset. So this value requests the server to enable and perform a rapid power shutdown. So normally power shutdown will occur. If you want to reduce the shutdown process, reduce the time, that is perform the shutdown rapidly, then we will use this subfunction. So this value requests the server to enable and perform a rapid power shutdown function. The server shall execute the function immediately once the key or ignition is switched off. While the server executes a power down function, it shall transition either directly or after a defined standby time to sleep mode. If the client requires a response message and the server is already prepared to execute the rapid power shutdown function, the server shall send the positive response message prior to start of rapid power shutdown function. That is, before shutting down, it has to send the positive response. The next occurrence of a key on or ignition on signal terminates the rapid power shutdown function. Right? So for those ECUs which are powered by battery only and not impacted by the ignition off and on, not powered by the ignition off on, for those, to enable this rapid shutdown part, we have enable rapid power shutdown, and to disable it we have this subfunction 05 which is disabled rapid power shutdown. If you're not clear, you can go back in the video and listen to what I have told to understand clearly, or you can read this section again. Now let's go back to the PowerPoint. So we understood what is a hard reset, what is a key off on reset, what is a soft reset, what is enable power shutdown, disable power shutdown. These are applicable only to those ECUs which are powered by battery and not does not switch on and switch off based on ignition. Hard reset is a function 01, key off on is 02, soft reset is 03. Mostly in the industry today we use hard reset and soft reset most of the times. These are very commonly used resets. This is a power sequence. So when hard reset is triggered, then ECU power up occurs. When soft reset is triggered, requested, then application startup. So it starts from that point of time. Next, coming to the UDS request response sequences. The request response order for this service is a bit different. Usually for other UDS services, when request is received, then the service is fulfilled and then a positive response is sent. But we cannot do that here. The service here is for resetting the ECU, and hence there is no active software available to send the response if the service is fulfilled first. So here we first do the service checks and send the positive response first and then fulfill the service by performing the reset of ECU. I have demonstrated this as part of these two diagrams. So usually what happens? The tester, which is a client, will send the UDS request. The server, which is a ECU, will perform the service checks that checks whether whatever is requested in the UDS service is possible or not, whether the format of the service request is there or not, whether the proper diagnostic states is there or not. So all the checks to perform the service is done, and if it is possible to perform, then it performs the service first, completes the service execution, and then sends a positive response. But here, if you do that, do the same. Here, what is the request of the service is to reset. Who sends this response and all? The software part, right? But if you perform the reset first, there is no software itself active in the ECU to send the response. So for this service, what is the sequence? The UDS request is received from the tester. The service checks is performed. If it is determined that it is possible to perform the service, fulfill the service, then first we send the response. Once that message is sent, then the service will be executed. We will see this one in detail when we will discuss about the implementation part later in this same video. Okay, so let us first see some of the UDS request response examples. So let's say we are requesting for soft reset. For soft reset, you know the subfunction is 03. For some of the things, for performing this ECU reset and all, it may be required that we need to be present in the extended diagnostic session first. So assuming that the tester first requests for the diagnostic session change, 03 is for the extended diagnostic session. So it is possible to enter. So extended session entered, and it sends a positive response that we have entered the extended session with the timing value. If you want to know what are these parameters and all, how this request service happens, then please view the diagnostic session control service explained, which I have done in previous video of this series. In the thumbnail and in the description, I'll be putting the link to that video as well. After the diagnostic session is changed from the default to extended, in extended diagnostic session, then we can request for the ECU reset. We are requesting for 03, that means it's a soft reset. So the soft reset is requested, all the checks are done, and assuming that all the checks are successful, we have to perform the soft reset. So 5103 is the response which we will get, and then here reset is performed. Similarly, you already know that in the subfunction, the MSB of subfunction is for suppress positive response message indication bit, SPRMIB. So if the soft reset is 03, then 83 is soft reset with suppress a positive response message. 01 is a hard reset, then 81, which is 01 is in binary format 00000001, and if you make the MSB as 1, then it will be 10000001. So this is nothing but 8 in hexadecimal, this is nothing 1, so this is a hexadecimal values. So if you are requesting for 81, right, and the ECU reset, then the hard reset will be performed, assuming that everything is proper, but you are not able to see any positive response here because we have requested to suppress the positive response. But remember that if there is a negative response, that will not be suppressed. This is suppress positive response message only. PRM stands for positive response message. This is not negative response message. If the response message is negative, then the reset will not be performed, but a negative response will be sent. Here in this example, we are assuming that the ECU reset can be performed. All the checks gave out positive result. So we were supposed to get positive response, but because the MSB of the subfunction is made as 1, so we will not send the positive response. The positive response message is suppressed. Coming to the next example of negative response, I told that the subfunction 0 is reserved, but if you request for ECU reset with a wrong subfunction, then it will give a negative response. 7F is a negative response message as SID. 11 means that this negative response is coming for the ECU reset, and 12 means what? Subfunction not supported. So this subfunction is not supported, and hence that response comes. So this is the NRC. NRC is negative response code. Negative response code gives the reason why the service request is not fulfilled. That reason is given by the NRC. And what are the possible NRCs this ECU reset supports according to the UDS document? These four are the minimum NRCs which has to be supported by the ECU reset service in any ECUs which are supporting the UDS. Hexadecimal 12, 1, 2, that is subfunction not supported, which we saw in this previous example. If the message length is incorrect, that is if we just request for 11, then you know that the service request should have SID and the subfunction. That is 1 byte for SID, 1 byte for subfunction, so total 2 bytes minimum is required. But if you're requesting only 11, then only 1 byte is requested, that is length is wrong, so then you would get 7F 1111, that is the service, and 13, this is the NRC you would get. Similarly, the conditions not correct. So in next slides we will see some of the prerequisites or conditions which can be applied for the service, that is it can be requested only in the extended diagnostic session, something like that. If that condition is applied, which is optional by the way, you can configure it, but let's assume that you have applied the condition for ECU reset while configuring such that only in the extended diagnostic session the ECU reset can be requested. Then what happens is, if you request in default diagnostic session the service 11, let's say 03, then you would get 7F 1122. The conditions is not correct. What is the condition? The condition is the extended diagnostic session is required, but you are not requesting it. Something like this. It can be any condition not correct. If a specific subfunction or specific NRC is not available for that condition, then this 22 will be sent. then security access denied. So you can configure in such a way that a particular security access level is required, security clearance is required for requesting of this ECU reset. And if that security clearance is not there and you request for this ECU reset service, then you will get a NRC 33. So till now we saw the theoretical part and the protocol part of the ECU reset. Implementation part we will see. As you already know, if you are following the AutoSAR, then the module, AutoSAR module, which takes a responsibility of implementing all the diagnostics UDS services is DCM. DCM stands for Diagnostic Communication Manager. This is a AutoSAR module. So if you are having a AutoSAR stack, how ECU reset is realized in AutoSAR. So you have the tester, which is the client, and all the software are within the ECU, which is the server, and this is the client or tester. So you do the ECU reset request is sent. So ECU reset request 1101, let's say something like this, or 03, whichever, and these 2 bytes will be put on the in the you can put 02 the PCI for the flow control part. 1103, these 3 bytes will be sent as a CAN data field on a physical request message, which is the CAN frame. You send that request in the CAN stack. This will be taken, and depending on the COM stack configuration, the CAN driver, CAN interface, CAN TP, PDUR will be surpassed, and PDUR will finally send this request part to DCM. So all those parts is not in the scope of this lecture or this video. Hence, I'm skipping that as together as the CAN stack. So ECU reset request will be sent to the DCM by the CAN stack. Depending on the subfunction requested, either hard reset, key off on reset, soft reset, this one will be requested to the DCM. DCM will perform the initial checks in DSD part, and if everything is proper, then what will it do is it has to request the BSWM module by a mode switch. The mode switch which will be activated is DCM ECU reset. For hard, we have the hard part. For key off on, we have the key on off. For the soft part, we have soft. If you understand the BSWM, then we have something called the mode switch that will result into the arbitration rules, and arbitration rules will result into the action lists which will trigger the actions corresponding to that in different modules. So the action list corresponding to the reset type, whichever reset type is requested, that will be executed, and it will be taken care by the BSWM module. Once the action list is completed, then the control goes back to the DCM. The DCM will send the positive response message to the CAN stack, and CAN stack will form the complete CAN frame and send it on the CAN bus, which will be received by the client. Once the CAN stack sends the frame on the bus, it sends a TX confirmation to the DCM. That is the API. DCM underscore TP TX confirmation. Something like this, the API will be there, that will be called. So once the DCM gets this API call, it knows that whatever response message I had sent, it has been transmitted on the bus. That's the meaning of this API call or this TX confirmation. Once the transmission confirmation is done, now we can perform the ECU reset. So it will trigger the mode switch of the ECU reset, but now with the mode of execute. When this mode switch is turned on, the BSWM has another action list for execution of the reset for the corresponding type, and that will be executed. Hence, in this way, the ECU will undergo reset, and after the reset is done, the ECU enters the default diagnostic session again. And this is how the ECU reset is handled in AutoSAR stack. So the CAN stack is involved, DCM is involved, and the BSWM is involved. Next, coming to the dependency of this ECU reset on diagnostic states. What are diagnostic states? There are two diagnostic states in UDS. One is the diagnostic session, and second is the security level. Diagnostic session, as we saw in the previous video, there are three main diagnostic session: default, extended, and programming. This is subfunction 02, subfunction 03, subfunction 01. There is security diagnostic session also, which is subfunction 04. Even the vehicle manufacturer and the suppliers can define their own diagnostic sessions as well. But these are the three standard diagnostic sessions defined by the UDS. Similarly, we have the security level also. So for some critical services, a particular security clearance is required. This is to ensure that the hacking and all those things does not happen. So these two together are known as diagnostic states. Each of UDS services has dependency on diagnostic state. Likewise, even the ECU reset depends on them. We can configure certain prerequisite diagnostic states for processing of ECU reset service. For example, ECU reset shall be performed only in extended diagnostic session, and ECU needs to be in security level 2 for processing of ECU reset request. So these kind of configurations and dependency prerequisites can be applied for ECU reset. So these are necessary but not sufficient condition for processing. Yeah, as it's self-explanatory, I think. So how do we do that? So if ECU is not in necessary diagnostic state, that is either not in required diagnostic session or doesn't have the needed security level clearance, then it directly sends a negative response with below NRCs for ECU reset request. Let's say the ECU is not in the requested diagnostic session, and that time you are requesting for ECU reset. Then you will get 7F 11 7F. This is the NRC. NRC 7F stands for service not supported in active diagnostic session. And the other one is if ECU doesn't have needed security clearance. And that time you request the ECU reset, then 7F 11 33. 33 we have already seen. So security access denied. But these are configurable. We can configure if any such necessary conditions need to be applied for the service, and if yes, then which diagnostic states exactly are needed. We can configure them. Next slide, we shall learn the AutoSAR configuration parameters, which lets us configure these things. So the dependency on diagnostic states, the configuration parameters. So you know there are two diagnostic states. One is the diagnostic session and second is the security level. If the dependency on diagnostic session is needed or not is decided by this configuration parameter, and on the security level this configuration parameter. The configuration parameters are shown here and the hierarchy is shown here. So in DCM, in the DCM config set, DCM DSC service tables are there, and in the corresponding DCM DSC service, here you will have ECU reset service. In that there is a configuration for DCM DSD SID table session level ref, right? That is this session level ref. So the reference to a session level in which the service is allowed to be executed. Multiple references are allowed. So if you don't configure anything, leave this empty, that means you can request this service then in any of the diagnostic session. In default diagnostic session also you can request this. In extended diagnostic session also you can request this, and so on. If you configure, let's say, the extended diag session in this configuration table, then if you request the service in default diagnostic session, then you will get a negative response. Only in the extended diagnostic session you will be able to request this service. So that's how you create the dependency on diagnostic session. Similarly for security level also. So in DCM, that DCM config set is there, DCM DHT service table is there, similar to above only. DCM DHT service is there, and DCM DSD service, which is the ECU reset, will be there. In that, there is one more configuration parameter called as DCM DSD SID tab security level ref. That is this configuration. So this is a reference to security level in which the service is allowed to be executed. Here also multiple references are allowed. So you will be creating different security levels in the DCM. So which security level is required for this service to be executed, those things you can add here. You can see this is a reference, both of these are reference kind of a thing. So reference to those security levels or diagnostic sessions are given, and if you are giving that references here, then only in those diagnostic states only this service can be requested. If that diagnostic state is not met and the service is requested, then you will get a negative response. So that's how you create the dependency on diagnostic states for ECU reset. So that's it for this video, guys. I hope you understood what is the ECU reset. Why do you request for a reset? When you request for a reset, then what are the different reset types you can request? What happens? What is the flow of the startup sequence? If you request for which reset types, then from which point of time does the startup sequence restart from in the ECU? What are the dependency on the diagnostic states? What are the different AutoSAR modules involved in realizing ECU reset? All these things are clear to you. I'll see you in next video. Thank you for watching this video. If you liked this video, then please leave a like, leave a comment, and subscribe to my channel so that you will not miss any videos which I'll be uploading in this series. Have a nice day and happy learning.